So now we're going to start naming the different types of carboxylic acid derivatives. So important now is learning the rules for the IUPAC nomenclature of these carboxylic acid derivatives. Okay? And in particular, we have 5 groups that we're going to be covering. First, we're going to be covering the acyl halides. We're going to be covering the acid anhydrides, or the anhydrides. The esters, amides, as well as the one that I feel is often overlooked, but it still is included in this chapter, and that's nitriles. So for each one of these, you're going to learn the various rules that's required according to IUPAC nomenclature on how to name these. So first up, we have the acyl halides. So the way that you do this is you're going to name the original carboxylic acid, but you're going to drop the ic acid ending and add the YL halide. So let's do some examples here. Oh, and first of all, I just want to point out that in general, when we talk about the acyl halides, we're talking about what it is that that's an R group, carbonyl, and a halogen. So let's look at this specific example here. So it's an acyl halide. And first off, I just want you to ignore the halogen there. And if that was a carboxylic acid, let's name it. So there's 1, 2, 3, 4. So it would be butanoic acid. Okay. Now, what we want to do is we want to drop the ic acid, and we're going to add the correct ending. So it's going to be YL, so butanoyl, and a chloride. So butanoyl chloride. Let's do another example. So in this example here, we have another acyl halide. Even though it's got an alkene in it, it's still going to be an acyl halide. Okay, so first off, once again, let's ignore the halogen and name this as if it was a carboxylic acid. And so if we look at that, we see that there's 1, 2, 3, 4, 5, 6 carbons in the what would be carboxylic acid, and there is a double bond, so it becomes hexene oic acid. And we have to give a locant for the double bond, so it's 1, 2, 3, 4. And then we have another functional group, this one right here. And so that's 1, 2, 3, 3-methyl, 4-hexenoic acid. Okay, now we want to drop the ic acid and add in the correct ending. So we add in a YL, so now it's 3-methyl, 4-hexanoyl bromide. The next carboxylic acid derivative that we are looking at are the acid anhydrides, or in organic chemistry class we usually just call them the anhydrides. I say acid anhydrides because these are from carboxylic acid derivatives. In biochemistry, for those who are in biochemistry, we talk about phosphoanhydrides, where one of the acyl groups has been replaced by a phosphate. Okay. So if the two R group, and just to reiterate, the anhydrides are carbonyl, oxygen, carbonyl, and another R group. If the two R groups are different, then you're going to still replace the term acid with anhydride, but you've got to name each alkyl group and put it into alphabetical order. Okay, so what happens if the two R groups are identical? You would name the corresponding carboxylic acid, just like before. You drop the acid and add the word anhydride. So let's do an example of these. So we have this example. Notice the two R groups are identical. Okay? So we only need to name one of them. Let's just ignore this side. If we only had that side and we named it as the carboxylic acid, it's 2 carbons, so that would be acetic acid. However, all we have to do is drop the acid and add in the term anhydride. So this becomes acetic anhydride. Forgive my, here, let me rewrite that. Anhydride. So now let's do an example where the 2 R groups are different. Okay? So we now have to name each individual side. So for example, this side as if it was a carboxylic acid, as well as this side as if it was a carboxylic acid. Okay? So let's start, and we have to put them in order of alphabetical order. So what I'm saying is the third word will still be anhydride, regardless. So let's look and see which one has a root that's higher in order. So, for example, the side on the left has 1, 2, 3. So it's going to be a propanoic acid derivative. And the side on the right is going to be 1, 2, 3, 4. Some type of butanoic acid derivative. So propanoic comes last in alphabetical order, so it's going to be the closest to the anhydride, because I like to work in reverse. So let's name it. I'm going to try to keep these color-coded correctly. And so it's propanoic, because if it was carboxylic acid by itself, it'd be propanoic acid. Okay. Likewise, we now need to name the one that would come first in alphabetical order. So it's 1, 2, 3, 4, which is a butanoic. And on carbon number 1, 2, 3, it has the bromo group. So it becomes 3-bromo. 3-bromo butanoic propanoic anhydride. It's kind of a mouthful and difficult to write out. However, many times we're talking about the symmetrical anhydrides. Those are the ones that are often the most useful in organic syntheses. So the next carboxylic acid derivative that we're looking at are the esters. And so esters have the designation of R, carbonyl, oxygen, and another R group. And the 2 R groups could be the same, or they could be different. Sometimes these are called alkyl alkanoates, just to give you an idea of how the naming goes. So these compounds will have 2 words in their name. The first word is the name of the alkyl group, which is designated by the R prime in this instance here. Then the second word is the name of the acyl chain, the R group, but you replace it, which I misspelled replace, you replace the ic acid, if it was a carboxylic acid, with the ending ate. So the hardest part here is really trying to determine which is the alkyl group and which is the acyl group. So let's just do some examples. Here is our first example. So first up, we have to determine, is this side the acyl side or is it the alkyl side? This is the alkyl side because it doesn't have the carbonyl group. So that's actually the one that we name first. So it has 1, 2, 3 carbons in it. So that would be propane, which becomes propyl. Here, let me erase that. P and redraw. Now we need to name the alkyl side. So first let's just think about what that means. Since it has 2 carbons, it would be called acetic acid. But what we do is we drop the ic acid, and we're going to add a different ending. We add the ending of 8. So this compound becomes propyl acetate. It could also technically be called propyl ethanoate, since acetic acid and ethanoic acid are the same thing. Let's do another example. Okay, so here's another example of an ester. We have to decide which side is the alkyl side, and which side is the acyl side. So let's look here. The side that's on the left, the way it's drawn, is that the alkyl side or the acyl side? That's right, that's the alkyl side because it doesn't have the carbonyl group in it. Okay? Whereas this other side does have the carbonyl group, so it becomes the acyl side. So let's go ahead and let's name this. I'll try to make this color coordinated as much as possible. So let's name the alkyl side. So for this alkyl side, we have a benzene ring. So we have two possibilities. Is this a benzyl group or is it a phenyl group? When the benzene ring is directly attached, it is a phenyl group. Remember, if it has a linking CH2 between the benzene ring and whatever it's attached to, it's called a benzyl group. So this becomes phenyl. That's the hard part right there. Now let's name what this would be. If that was only a carboxylic acid, it has 1, 2, 3, 4 carbons, and so we would say it's butanoic. It's 4, I mean but is 4, acid. However, what we need to do is we drop the ic acid and we add in the ending 8. So this is phenylbutanoate. Let's go ahead and do one more example. Okay, so I've now drawn this example, and I'll give you a moment to figure out which side is the alkyl side and which side is the acyl side. Is the side on the left the alkyl side? Or is the side on the right the alkyl side? Because we want to draw the alkyl, or name the alkyl side first. It's right. It is the side on the right because it does not have the carbonyl group. Okay? So let's go ahead and let's name the alkyl group. So we have 1, 2, 3, 4 carbons. So that means it's butyl. But now we also have things hanging off. We've got a methyl group here and a methyl group there. So this would become 2, 3 dimethyl butyl. Now let's name this side. If that was a carboxylic acid, what would it be called? That's right, it would be called benzoic acid. However, this is not a carboxylic acid, it's an ester. So we drop the ic acid and we add the ending 8. So this becomes 2,3-dimethylbutyl benzoate. So our next carboxylic acid derivative are the amides or amides. So these are the carboxylic acid derivatives that have, carboxylic acid derivatives that have an R group, the acyl or carbonyl chain, followed by a nitrogen, and you can either have 2 more R groups hanging off the nitrogen. These could be either hydrogens or they could be some other type of alkyl derivatives. Okay, these are actually quite easy to name because you would name it as if it was a carboxylic acid, but then you drop the ic acid and you replace it with amide as an ending. Okay, so let's work some examples. Okay, so we have an amide here, and we now need to name it as if it was a carboxylic acid. So let's just kind of ignore the nitrogen for the time being. We see that we have a 1. Oh, here, let me get a thinner marker. We have 1, 2, 3 carbons, and then we have this functional group in the alkene that we also need to name. So since it's 3 carbons, it would be a propanoic, but the double bond makes it propenoic acid. We have to give a locant for the double bond, and it's on carbon number 2. And now we have to name, hanging off of carbon number 3, the benzene ring. And since a benzene ring is directly attached to it, it's a phenyl group. So if that was a carboxylic acid, it'd be 3-phenyl 2-propanoic acid. However, it's an amide. So what we do is we drop the oic acid and we give it the ending amide. By default, it's going to be hanging off of carbon number 1. So we have 3-phenyl 2-propanamide. Okay, let's do another example. Okay, so we have an amide. So let's first name this as if it was a carboxylic acid. Since it has 2, it would become acetic acid. Okay, we drop the ic acid and we add the ending 8. I'm sorry, amide. 8. Amide. So acid amide. Uh-oh. We do have an issue here, though. And that's because we have a functional group hanging off the nitrogen. This is called a secondary amide. If there were 2 hydrogens hanging off of it, it would just be a primary amide. But you can actually have 2 or even 3 alkyl groups hanging off of the nitrogen, and we have to name those. Okay, and so it's a methyl group. So you just call it methyl, but you have to give it a locant. However, this locant is the N. It's a capital N, and technically it's in italics, but this is N-methyl acidamide. So let's do some more examples where we have a substituted amide. Okay, so here are 2 examples where we have substituted amides. Let's look at the one that's here on the left first. We'll name the 1, 2, 3, 4 carbons that has a carbonyl group. And so that would be butanoic acid. However, once again, we drop the oic acid. And we add in the end amide or amide. And we also need to account for that functional group, which is an ethyl, because it has 2 carbons. And we have to give it the locant N. So this is N-ethyl butanamide. Okay, let's check to see if that's correct. Just a second, let me see if I can get it to... N-ethyl butanamide. Alright, so let's go ahead and we will erase the that side, and we'll work on the one that's on the right side. So first up, let's go ahead and we will name the carboxylic acid portion. So we have 1, to 3 carbons. So normally that would be propanoic acid. Once again, we drop the oic acid and add in the ending amide. So propanamide. But now we have to take account to the fact that we have 2 methyl groups. So that becomes dimethyl. And we have to give it 2 locants. And you have to label both in dimethylpropanamide. You must put both ends. So let's see if we're correct. In dimethylpropanamide. The reason why that's important is because you could have a propanamide. 1, 2, 3. And this would actually be 2 in dimethylpropanamide. So the last carboxylic acid derivative that we're going to go over in this chapter really are the nitriles, which the nitriles, you have an R group, a C, triple bonded to a nitrogen. Okay? And these are pretty easy to name, and there are 2 IUPAC acceptable ways to name it. You can just add the nitrile suffix or ending to the alkane name, and I'll show you how to do that in a moment. Or the way that I personally have seen it done the most is where you would name the carboxylic acid, but once again you drop that oic acid ending and you add the ending O-nitrile. So let's look and do a couple of examples here. Okay, in this example we have 2 carbons, 1, 2. Okay, and so if we do it according to the first method, it would be called ethane if it was just the alkane. And then you would just add the ending nitrile, so ethane nitrile. Pretty simple. However, I've more commonly heard it referred to the other way, as if it's 2 carbons, it's called acetic acid. You drop the ic, or the oic acid part, and you just add in nitrile, O-nitrile, I'm sorry. And so it becomes acetonitrile. And that's typically the one that gets used more often from my experience. Let's do another example. Okay. You should look at this and try on your own, pause the tape or pause the video and try on your own to name it using 2 methods. And then I'll work through it as well. So take the time to pause the video and try to name it on your own. Okay, let's go ahead and let's name this together now. First, let's try the less common method, and let's name it as if it was an alkane. So we have 1, 2, 3, 4 carbons, and so it becomes butane. And hanging off of carbon 1, 2, 3 is a fluoro group. So this becomes 3-fluorobutane nitrile, because you just add that ending. Now let's do it the other method, and I'll change the color. Okay? So we would name the carboxylic acid, which the carboxylic acid would be 3-fluorobutanoic acid. Then we drop the oic acid and add in the term O-nitrile. So this is 3-fluorobutanoitrile. I hope that this tutorial on how to name the 5 different carboxylic acid derivatives is helpful to you in being able to name them, whether we're using them as substrates reactants or as products. Good luck!